We're looking at chemical reactions. So first, we know the types of reaction. There are 5, but the 4 most important ones to identify are these. First is synthesis, where many reactants combine into one product. Reactants, remember, are the stuff on the left. Products are stuff on the right. Decomposition is the opposite of synthesis, where one reactant is split into several products. Single replacement is when one reactant replaces another one that's inside a compound. So basically, there's one element, one compound, both of them are on one side, and that element is going to replace another element in the compound that's next to. And double replacement is very similar, except both of the reactants are compounds. And it's single and double replacement where both of these are ionic. So this is ionic compounds only, this is ionic compound only. Now let's look at this again. Okay, so single replacement. A plus BC, where you see A is the element, BC is the compound. A is going to take the place of B, or you can also take the place of C in some cases. We'll talk about that more later. Basically, A is going to take the place of B, so it's just going to become AC plus B. B is kicked out because it's replaced. Double replacement is the compound plus compound, in which B and D are going to swap. Because it's an ionic compound, swap partners, right? Oops. So B and D are going to swap. So A's new partner is D, and C's new partner is B. So this is A plus B is AB. Very simple. To make into 1. Decomposition, AB split into A and B. Very simple. 1 makes many. Then a combustion. This is the easiest one to identify because it contains only 3 elements: carbon, hydrogen, and oxygen, which is a hydrocarbon here with an X amount of carbons and a Y amount of hydrogens plus O2. And that's going to become into products H2O and CO2. No matter what, in any combustion reaction, the products will always be some H2O and some CO2. Also balancing. So for first step in balancing is to count the number of each element for each side of the reaction. Count the number of each element in the reactants. Count the number of each element in the products. Then find the tallies that don't match up, and then multiply accordingly to make them match up. Let's show what I'm talking about. We're seeing an example here. So sodium bromide plus calcium hydroxide is going to turn into calcium bromide and sodium hydroxide. So which type of reaction is this? If you said double replacement, you are right. Look, because sodium's new partner becomes OH, calcium's new partner is bromide. So first thing we're going to do is count the number of elements on each side. So set up a tally chart here, divide the reaction into the reactant side and product side. In the reactant side, there's 1 sodium, 1 bromine, 1 calcium, 2 oxygens, and 2 hydrogens. So it multiplies into the parentheses. On the product side, there's 1 calcium, 2 bromides, 1 sodium, and then 1 O and 1 H, 1 oxygen, 1 hydrogen. Now we counted it. Let's find the differences. So we counted up here. We're going to find the differences now. So what we want is both of these sides to be equal. But currently, the number of bromines on here is 2. Number of bromines on here is 1. Number of oxygens here is 1. Number of oxygens here is 2. Number of hydrogens here is 1. Number of hydrogens here is 2. So let's fix that. We can do this by adding coefficients in front of the compounds and elements here. So in these blanks, we're going to put coefficients to change the number. So first, let's start off at the top with sodium. So we're going to put a 2 here, okay? A 2 here. So the sodium and bromine. So we saw the number of bromines here is too many, right? So we're going to multiply this one by 2 by putting a 2 there. We're also going to multiply the sodium, but we can fix that later. So now the number of bromines are matching. So we still have these differences here. I'm going to put 2 here to fix the number of sodiums, and this in turn will also fix the number of oxygens and hydrogens at the same time. So 3 birds with 1 stone, and that is a balanced equation. I mean, reaction, not equation. See, look, we can count up the elements again, and then we can try and find any differences, and there will be none. Now, what if part of reaction is not given to you? Well, in that case, find the elements that are involved on each side. Remember, on each side, it'll be the same elements. There'll be no new elements on each side. Make sure that all the elements possible on each side. Yep. Balance charges for compounds. We'll talk about that later. And then this is the one, big one. Look for Bringelhoff. That means bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine for diatomic elements. When these elements are by themselves and not dashed in a compound, they will always have a subscript of 2. So let's look here. So we got calcium plus aluminum chloride. And then the product is something plus aluminum. So what type of reaction is this? If you said single replacement, you are right. You look here. 1 element, 1 compound. We can see here that the aluminum is being kicked out of the compound. The Ca is probably going to replace it. So first, we know that there's calcium, aluminum, and chlorine. On here, there's only aluminum, which means calcium and chlorine are missing on this side, which means we need to put them in a compound like this one. However, this compound is not correct because the charges don't match up. Calcium has a +2 charge and chlorine has a -1 charge. So we need to balance this compound's charges to ensure that it's an actual compound of calcium chloride. So now we can do the tally chart. 1 calcium on this side, 1 aluminum on this side, 3 chlorines. 1 calcium on this side, 2 chlorines on this side, 1 aluminum. We're going to find that this doesn't match. So we're going to multiply first the number of chlorines on this side by 3, number of chlorines on this side by 2. So that is going to give us 6 chlorines on each side, but it's also going to affect the number of calciums. We're having 3 calciums and 2 aluminums. That means we need to fix that. We're multiplying the number of aluminums here by 2 and the number of calciums here by 3. Whoops, I forgot to add the tallies here, but anyways, that should be a balanced chemical reaction. Now predicting, what if one side of the reaction is totally not given to you whatsoever? So first you need to find the type of reaction. As I said before, synthesis, decomposition, single replacement, double replacement, and combustion. So synthesis is 2 elements we combine. Decomposition is 1 compound on one side only 1 compound on one side. And then single replacement has 1 element and 1 compound. Double replacement has 2 ionic compounds. And the combustion has just hydrocarbon, which is C, and then some random subscript H, and then some random subscript, and then plus O2 on one side, and then the other side will be H2O and CO2. And we're going to, according to the reaction type, we are going to check the reactants, and then we're going to balance charges. Let me show you what that means. It's really confusing to word out. So here we got aluminum plus hydrogen. I believe that is sulfate. Yes, sulfate. We are not given the products here. So we need to first find out what type of reaction is this. You see 1 element, 1 compound. That is going to be a single replacement reaction. So that means we know that the aluminum is going to replace this hydrogen here, because cations always replace cations, and ions will always replace anions. So the product here is going to be, see, look, the aluminum kicks the hydrogen out, and then replaces its place in here with having aluminum sulfate, and then the hydrogen is by itself. Remember, Bringelhoff, hydrogen is diatomic, which means by itself it has a subscript of 2. We're going to balance the charges of this compound. Then we can tally. 1 aluminum on this side, 2 aluminums on this side. 2 hydrogens on this side, also 2 hydrogens on this side, 1 sulfur on this side, 3 sulfurs on this side, 4 oxygens on this side, and 12 oxygens on this one. We're going to first do it simple by multiplying the aluminums by 2, so these two match. Then we're going to do the sulfurs by 3, so these match, but this will also affect this and this, but we're going to fix that later. Then we're going to multiply the hydrogens by 2. Actually, if you notice here, go back a slide. Multiplying this by 3 made the number of oxygens here also 12, so this was balanced out anyway. These oxygens. So the only thing we really needed to fix here was the 6 hydrogens and the 2 hydrogens, which we can easily fix by adding a 3 there, and that is a balanced chemical reaction. Let's talk combustion. Combustion is a really hard type of problem to do because it's always just CO2 and H2O, and it'll just be like some random like arrangement of like carbon and hydrogen. So you really have to like try and figure out the best arrangement for each of these 3 elements. So let's count up each side here. So 2 carbons, 6 hydrogens, 2 oxygens on the reactant side. On the product side, 1 carbon, 2 oxygens, but then another one over here, so 3, then 2 hydrogens. So we can find out that none of these are matching. So let's first start with carbon, right? Because it's the easiest one here. It's 2 and 1. So we're going to easily just multiply this side by 2, right? So then there's 2 carbons here. These 2 are going to match, except the number oxygen is going to change. O2 times 2 is 4. Then plus another one is 5. And we can't make 2 into 5. We're going to have to start working with the hydrogens now instead. So we're going to multiply this by 3. So because 2 times 6 will be 3. See, H2 times 3 would be 6 hydrogens. But then that is also going to affect the number of oxygens it's going to add. So look, there's 4 oxygens here. But then now here is an additional 3. That'll be 7 oxygens. How do you make 2 into 7? You cannot. You need to find the least common multiple then, which is the least value number that the 2 numbers have in common that they can multiply by. Basically, we are going to try and find the place where we can find something that we can multiply to make the number of oxygens equal on each side. Now there is a number. It's pretty easy to find. Just multiply 2 times 7 is 14. So we need to get the number of oxygens to both be 14 on each side. This one will be easy. Put a 7 there, goes 14 because 7 times 2 is obviously 14. And then this right now is 7, so we're going to have to multiply this by 2, but notice how the oxygens split out, right? So that means we need to multiply each of these coefficients by 2, making this 2 a 4, and this 3 a 6. Remember what we adjusted? We're trying to make this into 14, so multiply each of these by 2. 2 times 2 is 4, 2 times 3 is 6. So now both these are 14, both these are the same, but now the number of hydrogens and the number of carbons has been messed up. There's 4 carbons and now there are 12 hydrogens. But this is easy. Look, 2 can go into 4 easily. A6 can go to 12 easily. And both of them need the same, to multiply by the same thing, 2. So we just simply add a 2 to there. So it becomes 4, that becomes 4, that becomes 12, that becomes 12. You can check again. And that's going to be a balanced combustion reaction. Thank you all for watching. I'm sorry I could not delve into more detail on some other types of reactions, such as like word problems and stuff like that. But it should be pretty easy once you like practice enough, you know. Thank you. Bye.